Good morning, everyone. I will present our review focused on the possibility of recycling the brewer spent grain through the direct composting process. And precisely, the aim is to evaluate if the physical chemical characteristics of the BSG are compatible with the parameters necessary for a correct performance of the composting process. So this work was a collaboration between the Department of Agricultural Science of the University of Sassari and the Institute of the National Research Council of Italy. So in accordance with the Ellen MacArthur Foundation, the main objective of circular economy model is waste reduction to a minimum, focusing on the sharing, reuse, repair, and recycle in a closed loop. So in such a way as to reduce as much as possible the pollution generated by anthropogenic activities. So in this model, two types of material have been identified: biological in green line and technical in blue line. So the biological material can be decomposed by microorganisms and can be reintegrated in the biosphere. Meanwhile, the technical material cannot be reintegrated. So typically, a large amount of biological material is produced by agro-industry activities. And precisely, the brewing industries produce a large quantities of byproduct. But this, how say, just my colleague before, Angela Bianco. So I can just say that the filtration step is the fundamental step because it separates the wort from the insoluble and integrated part of the malted grain, that is the BSG. So, but how many kilos of BSG are produced? The whole world BSG production was about 39 million tons, and for 3.4 million tons for the European Union, considering just the member state. So the disposal of BSG represents one of the major concerns for the brewing industries, because the large quantities generated, a low market value, the difficulty of their storage due to high moisture content, and their disposal as a landfill or by burning could be generated environmental pollution. For this reason, in the last few years, following the fundamental towards our circular economy, several ways to recycle BSG have been investigated. In this slide, I report the main ways of recycling the BSG found in the literature with the respective bibliographical references. So the main way of recycling still used today is through animal feed, and very few actors considering the possibility of enhancing the BSG for agronomic purpose or as growth substrate for earthworms, just Angela Bianco said before. So what is the composting process? The composting process is aerobic and exothermic, which leads to a stabilized final product known as compost, free of phytotoxicity and pathogens, and rich in nutrients. This process involves microorganisms such as bacteria, fungi, which can easily metabolize and mineralize simple organic carbon compounds. To produce, and this process can produce sulfite ions, heat, water vapor, ammonia, and greenhouse gases. So considering the development of the temperature profile, composting can be divided in three main phases. mesophilic phase, thermophilic phase, and cooling phase, called also second mesophilic phase. In the first mesophilic phase, the temperature range between 25-40 Celsius degree, and the microorganism metabolize easily degradable compounds, such as sugar or protein. The thermophilic phase, in the thermophilic phase, the temperature range between 40 to from 40 to 65 Celsius degrees. This phase is very important for elimination of pathogenic microorganisms. In the cooling phase, also called the second mesophilic phase, the temperature begins to decrease and reach the 40 Celsius degree. So finally, the stabilization phase includes the mineralization and the humidification of the more complex compound. So the first two phases are also called the active transformation, while the last two are also called slow decomposition. So what factor affect the composting process? So the most important is the CN ratio. The optimal range reported in the literature is between 20 to 30, and the CN ratio above 30 makes the process very slow, while CN ratio below 20 produce nitrogen losses by ammonium volatilization or leachate. So the second factor is the moisture content. As you can see, the optimal content reported in literature range from 16 to 65%. The moisture content above 65% can be generated anaerobic condition of the composting mass with the formation of bad odors. Meanwhile, a low moisture content below 40% reduce the microbial activity with the consequent slowdown of the composting process. So directly linked with the moisture content, we can find the oxygen concentration, that the optimal range is about 50%. Finally, the microorganisms are not more sensitive to pH and are able to proceed with degradation with value between 5.5 to 7.5. However, values higher than 8 play a fundamental role in ammonia losses by volatilization. So in this slide, I have reported the graphic representation of the characteristics of BSG that I found in the literature, comparing them with the optimal values, CN ratio, pH, and moisture content necessary for a good composting process. So as you can see, the CN ratio of the BSG range from 7.1 to 26.5 due to the high protein content, while the pH is between from 3.8 to 6.9. In these both cases, there are values that fall within the optimal range for the composting process, as shown by the graphic box plot with the vertical bars. Finally, the moisture content found in literature range from 70.6 to 81.3, with all values that are clearly above the optimal range for the composting process. So in our work, we also try to hypothesize two different mixtures to be used for the composting process. The equation was taken from the Italian composting manual written by our National Agency for Environmental Protection, ANPA. So this formula allows to quantify the kilos of BSG, these parameters M, BSG, needed to obtain a mixture with a desired CN ratio. In this case, was set equal to 30 in relation to the characteristics of the other material used. So in this context, we use the livestock manure as a starting material to promote the process, and wheat straw as bulking agent to reduce the moisture content and improve the CN ratio. So this equation was set up and solved considering once the solid fraction of pig slurry and once the sheep manure. So we have chosen these two categories of animals because they are most bred in Sardinia region. So the two tables show the composition of the two different mixture, considering the solid fraction and the sheep manure. So for the parameters for the BSG, reported, the values are the means of the values found in literature. Meanwhile, the wheat straw and the two manures, the investigated parameters were previously analyzed in a laboratory. So, but now we actually made the two previously proposed mixture, and these were compared with two different composting systems, the manual turning and the static composting. The composting process took place in 300 liters bin, and the result will be available soon, I hope. In general, composting could be an alternative way for recycling of BSG. However, the BSG is not suitable for direct composting, and therefore it is necessary to reduce the moisture content with the addition of a bulking agent, as a straw, wood chips, or sawdust, and it is necessary to improve the CN ratio, air spaces, and pH through the addition of carbon-rich byproducts. So, and finally, the last but not the least, livestock manure may need to be added as a starting material to promote the composting process. In this way, we are able to recycling also other byproducts and closing the loop. Thank you so much for the attention.